Okay, so this one says evaluate the limit algebraically. So when we're evaluating limits, we should always start with direct substitution. That should be your first choice. See what happens when you try direct substitution. If you get a 0 in the denominator, then you know you need to do more work. But you should always try to do direct substitution first. So when I plug 5 into this equation, I get square root 5 minus square root 5 in the denominator, which is 0. And that's bad. And that tells us direct substitution does not work. So the other two methods are factoring and rationalizing. This guy has a square root in it, so we're going to go with rationalize. Okay, so we have limit as x approaches 5 of x minus 5 over square root of x minus square root of 5. To rationalize, I'm going to multiply the numerator and the denominator by the conjugate. So I'm going to multiply both the numerator and denominator by square root of x plus square root of 5. So in the numerator, I'm just going to leave it as x minus 5 times square root of x plus square root of 5. In the denominator, I'm going to sort of FOIL it out, right? I'm going to do square root of x times square root of x and square root of x times square root of 5. When I do square root of x times square root of x, I end up with x. And then I get plus square root of 5x. Okay, and then similarly, I'm going to do the next term. I'm going to do negative square root of 5 and negative square root of 5 times square root of x and negative square root of 5 times square root of 5. So I'm going to get minus square root of 5x and then minus 5. So square root of 5 times square root of 5 is 5, so I get minus 5. Okay, so if I look at this and simplify a little bit, I get x minus 5 times square root of x plus square root of 5 divided by, in this denominator, these square root 5x's cancel because one's positive and one's negative. So I'm left with x minus 5. And now if you notice, I have an x minus 5 on the top and the bottom, so I can cancel those out. So I'm left with limit as x approaches 5, square root of x plus square root of 5. So now what I'm going to do is just try direct substitution again. There's no more denominators, so I shouldn't get any errors when I do that. So I'm going to plug 5 in, so I get square root of 5 plus square root of 5, or 2 square roots of 5.